Okay, so let's look at the first one. So you know that basically I have 3 sections. You can have a look at the other section as well. Okay, but in your case, we are just looking at section 3. Okay. Okay, so let's have a look. So first one is Bank Muamalat reports that 7% of its credit cards holder will default at some time in their life. So you can see that you have, what is that 7%? You have the pie, right? The percentage. But then 7%, is that a lot? Is that lot? Very small, isn't it? Okay, and the IUM branch just mailed out 12 new cards today. Okay, so basically you are given the pie which is 0.07. This is very small default. And then you are also given how many? They mail out 12 new cards. So how many? The cards is 12. Okay, so remember your quiz covered a few chapters, chapter 6, 7, and 8. So what is this example? The part is, what is that?
Boson.
Yes, this is the boson example. The pie is given, but the pie is extremely small, less likely to occur, less likely that people will default, and then the n is given. So in the boson, remember, um, you have to find the mu. So you know how to find the mu, right? So to find the mu, even though they didn't give you the information for mu, you can find the mu by taking pi multiplied with n. Okay, so pi multiplied with n, you can see the answer on the left side, 0.84. So okay. So basically, I don't know. Have you seen the question? What is the probability that zero will default? Did the question for you is complete or it is stopped here?
Stop there.
Really? Okay. Well, I didn't really realize that it stopped there. Okay, let me just allow some of your friends to join. Only one. Oh, why didn't you tell me that it stopped there? Because this is not a complete set of questions, right? How would you know that? Because you need to find the x. Without the x, how will you know what kind of question are we talking about, right? So somehow the question here, what is the probability that none of the credit card holder will default? That's why you add. It's actually 0. How would you answer this question if, let's say, there is no question to this question, right? Um, so I will double check the question if, let's say, it is just stopped there. So and none of you tell me that you don't have a proper question here.
Madam,
Ah,
Madam bagi tahu soalan tu kat kelas.
okay. So I did mention that none of it, isn't it? I did?
Yes, madam.
Okay.
Yes.
I'm about to give you bonus mark. Luckily, you are being honest to me. So that's good. Okay. So when it is 0, so x is 0, so just plug it into the Poisson formula, you will get the answer right away, which is this one. Okay. I'll just keep moving until you ask me a question. Okay. Which of the following is not a characteristics of a binomial probability distribution? The rest are the characteristic except the last one. The number of trial is 2. Remember, you can have many number of trial. You can have 3, 4, whatever. Not necessarily that it will be 2. Okay. Um, Number 3. So basically, this is just like straightforward answer. There is no way that the number of trial will be 2. Okay. A study of long distance phone call made from IUM finance office revealed the length of call in minutes. Okay. In minutes. So this will be the moment that I see minutes, this will be continuous. Follow the normal probability distribution. The mean length of time per call. Okay, so let me just write down the information, right? So that you can see clearly. So the mean equals to 4.2 and the standard deviation equals to 0.6. What is the probability that you want to find the probability that X lasts more than 5 minutes? Okay, once you have listed down the information, the next step is you have to draw the diagram. Okay, let me draw the diagram here. What is the middle? Is 4.2. Remember the middle? You should plot the distribution in the middle first so that you know which area are you talking about. So 4.2 is the middle, but you want to know X is more than 5. So since the middle is 4.2, so maybe 5 is somewhere here, but you want to know more than 5. Okay. So let's just apply the formula of the Z, right? So, so Z equals to X minus mu over sigma. What is your X here? More than 5. 5 minus mu. 4.2 over sigma. 0.6. What will you get here? Do you have your calculator with you? Can you tell me what is the answer? I thought that someone is just joining. What is the answer? 5 minus 4.2 divided with 0.6. Anyone?
0.33.
0.33?
1.33.
1.33. Okay. Okay, everyone, please double check. So let me assume that this is correct. It is just the Z. This is not probability yet. How to find the probability? Go to the Z table. So where is our Z table? So 1.33, this is 1.3 and the 3. 0.4482. 4482. Are we done? Not yet, right? Because the area that you are looking for is just between 5 to 4.2. Between 5 to 4.2. This is the area that we have computed. 0.4482. So we want to find the shaded area. So how to find that? Of course, you will take 0.5 minus the one that you have computed. Then you will get the answer here, which is this one, 0.0918. Okay? I will keep moving until you stop me and ask questions. Okay, the next question. The means of the normal probability distribution is 60. Okay, so let's write it down. The mu is 60 and standard deviation is 5. About what percent of the observation lie between 50 and 70? So they already give you the x, 2x. x1 is 50 and x2 is 70. You want to know the percentage, right? So you want, if let's say you want to draw a diagram, okay? So you want to know what percent of the observation lie within the mean. This is the mu. So you want to know this area. So x1 here, x2 here. x1 will be 50, x2 will be 70. So you want to know what is the percentage here. Okay, so this is actually the examples of what you call empirical rule. Still remember the formula of empirical rule? You have mu plus minus k standard deviation. So the mu will be given 60 plus minus k. You have to figure out because this k will give you the percentage. Standard deviation is 5 here. But then now before this, the k, they will give you the percentage and then you will have to find the x, x1 and x2, which is the range. But now x1 and x2 is already given. The x1 is 50, x2 is 70. So your task is to find the k, the percentage. What is the percentage that lie within the mean? Okay, now you have two numbers, right? To answer 50 and 70. 50 is when you use the minus, 70 when you use the plus. For example, I use the minus. Okay, so let me rewrite here. So 60 minus k you have 5, you will get 50. Okay, now you just rearrange, you will get the K value. So how to do this? For example, you put 60 here, 50 minus, and then K, move it to the right side, you will get plus K5. So 60 minus 50, what will you get? Everyone? 10.
10.
Okay, so 5 and K, when you move the 5, you divide by 5. So what will you get? K equals to 2, right? So K equals to 2. So is this the answer? When you look at the answer, you have 65, 68, 95, 99. Remember in the empirical rule, okay, so if let's say K equals to 2, it is equivalent to 95%. If let's say later on you find K equals to 1, it is equals to 68%. If let's say you find the K equals to 3, the value of your percentage is 99.7. At the moment, K is equals to 2. So it should be 95%. That's it. The last question. This question can be solved within 5 minutes, but I give you more than that, right? Okay, let's have a look at the last question. Mal-age tests were conducted on a randomly selected samples of 100 newly developed automobiles. So many. So let's just list down the information. Okay. Okay, so you have N, you have N equals to 100. The sample mean view was, this is the sample mean. Okay. 50,000 miles. With the population standard, okay, you have sigma 3,500. What is the okay? What is the best estimates of the average population? Okay, anyone got it right, or you don't know how to solve this question? Anyone got it right?
Yes.
Yes. Wow, you must be very smart, because I somehow didn't notice that the question asks about the best estimate. Best estimates is not under chapter 6, it's not under chapter 7, it's not under chapter 8. It is under chapter 9. This is what you call point estimates. Okay, even though the question is easy, best estimate for your population is just your sample mean, but because we haven't covered this, so you shouldn't be tested on chapter 9. Okay, so saying that, everyone should get bonus mark for this. Okay. Okay, so we will see this in the coming chapter, which is today. Okay, so make sure that if you got it wrong, please come and see me to claim your marks. Okay, so that's the end of the quiz. So now let's look at our chapter, which is chapter 9. So I hope that I can make it physical, but because I have a flu, okay, so I don't think it's fit for me to go to the class, or else you will also be affected. Okay, that's why I have to confine myself to stay at home. Okay, but I cannot cancel the class, because or else you will miss many things. It's hard to find the replacement. That's why we have to make it online. I hope that everyone is okay. So if I go too fast, let me know. If you don't understand, let me know as well. Okay, so this chapter is about estimation and confidence interval. Just to let you know, well, among all the chapters that you're going to learn, or you have learned, this is the only chapter that have many formulas. Okay, in the previous chapter, you're going to have chapter what? Chapter 6, 3 formula, chapter 7, just 1, and so on. So in this chapter, you're going to have 6 formula. Okay, that's a lot. But by saying that's a lot, doesn't mean that this chapter is hard. It's just that you will be seeing many formula. But the formula are very straightforward. Okay, the tricky part is only one thing, which I will explain later on. Okay, so the first part of it is point estimate that you have been tested, which was my fault. Okay, you should get the bonus point from that. Confidence interval, you have sigma is known when you're going to use the formula. When it is unknown, and then you have the formula for population proportion, sample size, the same thing, you have population mean and proportion, and finite adjustment. Okay, we will look at the formula one by one. Okay, so what does the point estimate says? It says that there is no way for you to be able to know the population, right? Population is huge. And if you don't know your population, of course, you cannot compute your mu, population mean. So because of that, we use, what do you use? You use sample mean as the best estimates of your population mean. So whatever the value of your sample mean, we assume that that is the value for your mu. Okay, you don't have to use calculation. It is there, but at least you have to learn what it is, right? Next, confidence interval. Okay, interval is just a range, your estimation to number. You're going to see the formula later on. You have plus minus. Okay, so of course, because you don't know so you don't know what is the mu, right? What is the population mean? Because you don't know population mean, you have to kind of estimate. For example, population mean is 5, but you don't know population mean, exact number, which is 5. So what you're going to do, you're going to estimate, okay, maybe the range of population mean is between 2 to 6. So you are assuming that when you have the estimation, the population mean should be within this range. Okay, that is the only way of you to estimate the mu, because you don't know about it. So you give two value, the lowest value and the highest value. So you assume that the population mean should be somewhere in the middle. Okay, should be somewhere within the range. Okay, so confidence interval is just to tell you how confident you are that your estimations of population mean or population mu is within your range or within your interval. So let's look at the first formula. What is it? Okay. So the first formula, when the sigma, what is sigma? Population standard deviation. When sigma is given, you have to use the distribution. So what is this z distribution? Okay, this is the formula. X bar plus minus z, you have sigma over square root of n. Okay. Okay, so basically in this chapter, you don't have to worry about all the number. This x bar will be given, sigma will be given in the question, and will also be given. So your concern is that how to find the z, because they will not give you the z straight away. They will give you the confidence interval in terms of the percentage, and you have to convert into z value. So let's look at the question. Before the question, let's see how do they convert it. Okay, so let me put it here. So if let's say your confidence interval is equal to 95%, how do you convert this into Z? So first, you have to change this percentage into a number, 0.95. And then you have to divide by 2. Why is that? Anyone? Why do you have to divide by 2? Because in your distribution, you're gonna have two-sided. What are the sided? Okay, I don't know where should I write it. So maybe here. Good. So the middle is 0. You have the negative side, you have the positive side. You have this left side one tail, another side another tail. That's why you have to divide by 2. Okay. So 0.95 divided by 2, you will get the value of 0.4750. This is not yet your z value. You have to go to z table to convert it into z value. So what will you do? Go to z table. Table. Okay, 0.4750. 4750. Where is this 4750? It's here. Okay, so what is the z value? look to your left, 1.9, look up, 1.96. This is your Z value. 1.96. You got the answer straight away. Okay. The same thing if let's say they give you the confidence interval equals to 90%. So you have to convert it into a decimal, 0.9 divided by 2. You will get a certain number. And then you go to your Z table and you will see that the Z table, the Z value is equals to 1.65. Okay, you can try to practice that as well. Okay, so let me look at the real example. Okay. So what is it? It says that a random, okay, let me use different color. What color I haven't used? This one. Okay, it says that a random sample of 49. So list down the information n equals to 49. Sample mean x bar equals to, this is a lot of number, 45,420. Standard deviations of the population. So basically this is your population standard deviation, that is sigma. So sigma is given, which is 2050. So the question asks, what is the population mean? Remember, you don't know your population mean. You are just given n, x bar, and sigma. So you can use x bar, the sample mean, as the best estimations of population mean, which is 45,000 plus. Okay, and then what is the reasonable range of value for the population mean? So you want to know your population mean estimate. Okay, you cannot find it except when the question gives you the confidence interval. This is a slide, right? So it's not complete. When you look at the second part of it, they give you number 2. The confidence interval is equals to 95%. So they give you confidence interval 95% because you are using Z. So confidence intervals of 95, the Z value will be 1.96. We have actually computed it just now. So just apply this formula, x bar 45,420 plus minus Z 1.96 sigma. What is the sigma just now? You multiply with 2050 divided with square root of n 49. So giving this information calculation, you will get two value, two range. You start with the negative because you want to find the lowest value, and then you later on you apply the positive so that you can have the higher value. Okay. So this is how you want to apply the formula. And sometimes the question also asks, how do you interpret this result, this range, this estimation? So you can say in two ways. First, you can say that you are, because you're, okay, let me use this. Because you are using confidence interval equals to 95%. So you can say that you are 95% confidence that the population mean will be within this range between x1 and x2, whatever the number is. Or you can also say the population mean, the range of the population mean is between x1 and x2 using 95% confidence interval. So you can put confidence interval in front or you can put it at the back. Both are the same. Sometimes the question also can ask you, well, compute the margins of error. Okay, what is this margins of error? So margins of error is part of the formula under your population mean. Where is it? The second part of it. This one. The Z multiplied with sigma divided with square root of n. This is what you call margins of error. Okay, sometimes the question will ask you the margins of error, sometimes they ask you to compute it. So you have it in the second part of the formula. Okay, so I'll keep moving until you stop me. Well, if let's say the sigma is not given, okay, you have to use the t distribution. Okay, so the formula of t distribution is very similar. What is it? X bar plus minus, instead of z, you are using t. Instead of sigma, you are using sample standard deviation divided with the square root of n. Okay. So t distribution is very similar to z. They are all what we call um, there are bell curve, but because in the Z distribution, okay, you know the sigma. Z, the sigma is known. Okay, so when the sigma is known, so when you estimate the what we call the distribution, basically you are making less error. Means that this is, for example, the middle is the true value through estimate through number of population mean. The middle is your mu, right? This is the true population mean. When you use Z, so your dispersion is not so large because you know the sigma. But if you are using T, you don't know the sigma. So can you imagine when you don't know the sigma, of course your what we call your error will be larger. Okay, so it will be more spread out. So the variance will be even larger. That's why you have a flatter shape, more spread out in terms of the variance, more error. It says. Okay. So now, okay, as I mentioned to you, X bar will be given, S will be given in the question, and will also be given. Your task is to convert the confidence interval into Z or T value. Okay, Z has to be referred to Z table, T has to be referred to T table. So they have different way of converting the value. For example, here you are talking, let's look at my left side. Your confidence interval, let me write it here. Confidence interval equals to 95%. So for the Z just now, you will get 1.96, right? Okay. But for T, you will get a different value. The value will be bigger because your distribution is flatter, more spread out. Okay. So for T, you have to know what is the degree of freedom. The formula of degree of freedom, n minus 1. For instance, your n here is 10. 10 minus 1, your df is 9. So let's look at the T table. So this is the table. Scroll down a bit. This is student T distribution. This is your T table. Okay, can you see this is the confidence interval? Okay, and then what is the confidence interval? 95%. You can have many percentage, but your question said 95. So follow your question. And you can see on your left side is the DF, degree of freedom. So what is your DF? 9. So from 95, you have to scroll down into 9. So you will get the T value is 2.262. So your T will be 2.262. Okay, this is how you find the T from the confidence interval. So let's look at the question, right? You have to know how to apply the question. Okay, so a sample of 10 tires. So you are given the information. Let me put the information. Where is it? Here. Here. N is equals to 10. Okay, and then your sample mean X bar equals to 0.32. Standard deviation, because the first thing that you saw is a sample mean. Okay, this is about mean, a sample. And the word after that, standard deviation. So the standard deviation also follow the sample standard deviation. Okay, so it's S, 0.09. So you are given the S, you are not given the sigma. So you have to use T distribution. So construct a 95% confidence interval. So confidence interval is 95%. So remember, we have computed it just now. Your n is 10. You minus 1 to find the df, you get 9. So for the T distribution, confidence intervals of 95, you will get the T equals to 2.262. Okay, now the question asks you to apply the formula. You want to see what is the population mean. Okay, so to apply the formula, so this is the formula that we're going to use. X bar, 0.32 plus minus T. Just now you have computed it, 2.262. Multiply with S. S is 0.09 over square root of n. You will get what? Given this working, you will get two numbers. Okay. Okay, if let's say you got, if let's say, okay, the number is, let me just put it here. The number is already there, right? On my left side, you got the confidence, the interval is between 0.256 and 0.384. This is the two range that you have estimated. Suddenly the question asks you, will it be reasonable for the manufacturer to conclude that the population mean remaining is 0.3? So you want to know, is it, can you say that it is 0.3? If let's say 0.3 is inside your interval, yes. If it is outside the interval, of course your answer is no. But at the moment, you have 0.25 until 0.38. So 0.3 is inside your interval. So you can say yes. Okay, if let's say they said, is it possible to say that the proportion means amount of thread remaining is 0.1? 0.1 is outside your range, so cannot. This is fine, this is cannot. Okay, next. So let me open a new one. Okay, what is this? Okay, you have proportion. Proportion is what? It can be fraction, it can be represented in percentage. So let me write the formula. So when you have x or n in the question, you know that this question is asking about proportion. Well, sometimes they don't even give you x or n. They give you in terms of percentage. Still, you know that this will also ask about proportion. Okay, let's look at the question straight away. Oh, before the question, you have to know what is the formula, right? Okay, let me write the formula here. What is the formula? P plus minus V multiplied with the square root of P 1 minus P over N. Okay. Okay, this union is actually considering to merge with the other company. Perhaps this company is about to go bankrupt. So they want to merge with other companies so that they can remain in the market, right? But then at least 3/4 means that 70%, 75% of their member should approve the merger, or else they can simply merge. So now it says that a random sample. So sample is your n equals to 2000. Out of this 2000 sample, 1600 claim to vote. So this is your x. X is the number of success from your sample. Remember your probability? So x is 1600. So you can see that, oh, you have the n, you have the x. So you should be able to compute the proportion, right? This should be the proportion question. Okay. So now, what is the estimates of the population proportion? So you have to apply this formula, x over n. So what will you get when you take 1600 divided with 2000? Anyone? What will you get? 1600 divided with 2000. So your proportion will be around 0.8. So you have, not yet. Okay, because I'm about to say just plug into the formula. You can. So you have proportion. Let me use different color. This one. So proportion is 0.8 plus minus, and then I see z. You have to have the z information, which is confidence interval. What is the confidence interval? They mentioned that the confidence interval is 95%. So remember, okay, this is the thing that you have to remember. For the proportion, you only will use z. For the population mean, you can have z or you can have t distribution. But for proportion, there is no t distribution. You will only use z. Okay, so confidence interval for the z, we have computed it before, 1.96. So just plug in 1.96 multiply with the square of 0.8 multiply with 1 minus 0.8 over n. What is the n? 2000. Given this information, you will get two range, whatever x1 and then x2. Okay. So I'll just keep moving. Okay. The next one is you want to determine the sample size for the mean. Okay. I don't know whether I have space or not. I think I do. Mm, hmm. Okay, maybe we open a new one, right? Okay. So what is the formula for sample size for the mean? So n is the sample, right? Z multiplied with your standard deviation, sample standard deviation into the power divided with the margins of error and then squared. Okay. So as I mentioned to you, all the information will be given in the question as E, but you have to convert confidence interval into Z value. That is the only tricky part in this chapter. Once you know how to convert it, whether convert into the T value or Z value, you can master this chapter easily. Okay, so let me keep moving. Look at the question. What is the information given to you? Okay, the information given is that she can tolerate a margins of error. So error is given equals to 100. She will also prefer to report the CI confidence interval 95%. This is Z, right? So 95% of your Z will be 1.96. The students found a report blah 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 with the standard deviation. Your standard deviation is 1,000. Okay. Someone is, you want to ask question by turning your microphone? Brothers, you want to ask question? Okay. I'm about to call your name, but luckily you already turned it off. If you have question, just let me know, okay? Okay. So now, this one. Okay, it doesn't matter whether you are using S or sigma because uh, in the formula you are using Z. Okay. Okay. So now let's just plug it into the formula. Okay. What do you have? Z here is let's apply the formula 1.96 multiplied with your standard deviation. You have 1,000 over E. What is your E? 100. And then don't forget squared, and then you will get the answer straight away. Okay, so somehow let me put the answer 384.16 because you are talking about sample. Remember, sample is individual. It could be person, it could be something, but sample, you cannot say that I meet 1.2 friends. You can only say I meet one friend or I meet two friends. You cannot say 1 point something. Okay, because it is a person. So for the sample, you have to round it up into a whole number. Instead of 384.1 something, 385. I know that in maths, when you have 384.1, you will round it up into 384, right? But instead, in statistics, you want it to be conservative, you round it up. You want to make sure that this 0.16 should be also included in your estimation, in your answer. Even though you got the answer of 384.01. So you also have to say 385 so that you will also consider this 0.01%. Okay. So next, this is the sample size for proportion. So let me just use the same page. It's just a different color. Okay, what is the formula? The formula is n equals to proportion 1 minus proportion. You have the Z over the margins of error squared. Okay. Okay. Let's look at the question. Okay. So the students wants to estimate the population proportion. Okay, that's why they have to mention population proportion with the margins of error 0.10. Okay. So list all the information down. Error is equals to 0.10. Prefers a level of, so the confidence interval is equals to 90%. Okay, so remember 90% for the Z, when you refer to the previous slide, is around 1.65. Okay, and then he has no estimates for the population proportion. So when you talk about proportion, sometimes they will give you n as well as x. Sometimes they will give you the percentage. But now he has no estimates of the proportion. When you have no estimates, means that you are not sure. When you are not sure, it's if like you are 50-50. Okay, so you can write here the proportion is equals to 0.5. Okay, so now just plug it into the formula, right? Let me see what color do I want to use. You have P, which is 0.5 multiplied with 1 minus 0.5 multiplied with the Z. Z is 1.65 over E. E, what is your E just now? 0.1. And then don't forget the square. You will get the answer straight away. Two estimates. Okay. You can see that the slide has given you 3 decimal point, but in our Z value, they will give you 2 decimal point. So just use our table. Okay. This is the last one about finite population adjustment. When you gonna use it? Okay, so you have to remember, we always assume that population is huge. Okay, so there is no way for us to know that to know the population. And of course, when you don't know the population, you don't know the population mean. But sometimes the question gives you the population, but the formula has assumed that there is no way for you to know the population. So when the population is given, so you have to adjust your formula. How to adjust it? You have to multiply with square root of capital N minus N over capital N minus 1. Only if they give you the population number. Okay. So let's look at the example. Okay. So you can see here, there are 250 families in this Pennsylvania. So family is number, right? So I can see that, well, in this Pennsylvania, there are, in total, they only have 250 families. So this is telling me, well, this is capital N, the population. Oh, this is too small. This is capital N. But just in case some of you think that this is sample, don't worry. The next sentence will tell you this is population. So let me just put it here. Okay. 250. And then a random samples of, you can see that a random sample. A random sample means this is your sample. This is your small n. 40. The moment that you see that capital N is given, population is given, you have to adjust the formula, right? And then reveal the mean. The X bar is for 50 and standard deviation, because this is from the mean, so standard deviation is as 75. Okay, and then they give you also confidence interval equals to 90%. Okay, so I'll just skip to second question number 2 instead of number 1, because the population mean is just asking about your point estimate, which is equals to your X bar. So develop a 90% confidence interval for the population mean. So you have to use the formula of population mean. What is the formula of population mean? X bar plus minus t, because you don't have the sigma, multiplied with s over square root of n. Okay, but because you have this capital N, so you have to adjust by multiply the adjustment formula, which is square root of capital N minus n over capital N minus 1. Okay, since you have all the information, just plug in and put it in the formula. That's it. Okay, so the population adjustment is just telling you that when the population is given, you have to adjust the formula. How to adjust? Just multiply with the adjustment formula. That's it. You can apply this in the population mean. You can also apply this in the population proportion. Okay, just multiply with this adjustment. When I said this adjustment, you just multiply by this formula. Okay, I think we have covered the slide. So let's go to the tutorial. Okay, everyone, I'm assuming that you have your your textbook with you. Go to page number 337, question 7. Where is this textbooks? 337, question 7. Okay, so I know that this is your activity in tutorial, but because we cannot form a group, okay, so let we solve this together. Okay. So the first thing you have to do, list down the information. Okay, you have population standard deviation. Sigma is given 2.3. So let's just write it down. Sigma is given 2.3. What else? Random samples of 60 cell. Random sample. 60, n is 60. And the mean number of, so the mean is, this is like because you are talking about random sample. And then you have the mean. So this is the sample mean, 8.6. Okay, I will just skip question A because I have explained this many times. I will just go to question 7. Develop a 99% confidence interval for the population mean. So your confidence interval is equal to 99%. Because sigma is given, you have to look at the z distribution. So how to do it, everyone? The same thing. Change it into a number. 0.99 divided by 2. What will you get? Anyone with the calculator? Anyone?
0.49.
0.49.
0.99.
5.
5.
495. Okay. So let's go to the z table. 0.495. Where is the z table? Table. 49. This is 494 already. 494, 49. We have these two value. 4949, 4951. Which one is the closest to 0.495? Anyone? Number 1 or number 2? The first one or the second one? Number 2, right? So how to do it? How to find the closest one? Just take these two value minus with 0.495. The one that will give you the closest one is the right one. So number 2, which is 2.58. So the z here is 2.58. Okay, let's go back to the question. Okay, you want to find, right? So you have to apply the z formula. What is the z formula? Very similar to t. You have here x bar plus minus instead of tz, and then you have sigma. Okay, so where is still x bar? 8.6 plus minus z, you get 2.58 multiply with the sigma. What is the sigma? 2.3 over square root of 60. So by having this, you start with the minus so that you will get a smaller estimate first, and then start with the plus. You will have the larger estimate. So put this in the calculator, you will get the answers right away. Okay, for example, you get the answer of this is like maybe 2, this is 5, for example. Question C, interpret the meanings. Remember the interpret? You can say that your estimations, or you are like 99% confidence that the estimations of your population mean is between 2 to 5. Or you can also set the population mean estimation is between 2 to 5 using 99% confidence interval. Both are the same. Both are okay. Okay. So let me move to the next question.
Madam, I have a question. This one no need to round off ke?
Which one? The answer?
Yes.
Because estimation. So estimation, you will have some decimal points. But when you talk about sample is a percent. So you have to round it out. For estimation, no need. You can maintain 2 decimal point. Okay? Here.
Thank you, madam.
Okay, next, go to page number 347, question 15, 347. 15, where is the 15 one? 47. I just want to scroll a bit and then, okay. Okay, this is the 15, number 1. Okay. Okay. So this owner wishes to determine the proportion, blah, 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 blah. He surveyed 100 customers. So customer should be N equals to 100, and find that out of this 100 customers, 80 paid at the pump. So 80, remember, X is the number of success from the sample. So X is 80. So whenever you see N as well as X together, they should ask you about proportion. Look at the first question. Estimate the value of population proportion. Because this is the example from the textbook, of course, they will mention proportion. But in the exam later on, they will drop the word proportion. So they will say, estimate the value of the population. So you have to know this is about proportion because you have X as well as N. That is the keyword. Okay, so you have to refer to the population proportion formula. Do you remember the formula? I don't remember your formula, right? So this is your formula for proportion. Let me give different color. So proportion equals P plus minus Z multiply with the square root of P multiply with 1 minus P over N. Okay. Okay. Estimate. Okay. Estimate the value of population proportion. So you know how to find. Okay, let me find a different color. How to find, the question asks about how to find the P, the proportion. What is the formula of proportion? You only have X over N. So your X is 80, your N is 100. So by having this, you will get the value of 0.8. So develop a 95% confidence interval for population proportion. So next they give you confidence interval equals to 95%. So remember, for proportion, you will only use Z. Don't think about T. Okay, so for the Z, if let's say the confidence interval is 95, the value will be 1.96. Okay, just plug in the information. So proportion is 0.8 plus minus, let me use different color. Color, we have blue. Okay, so proportion, this is the formula, right? So 0.8 plus minus Z is 1.96. Multiply with this square of 0.8. Multiply with 1 minus 0.8 over, what is the N just now? 100. See, they are very straightforward. Just plug in. The only tricky part is that how to convert confidence interval into the Z value or into the T value. Once you know it, easy. And then the next question, interpret your finding. The same thing. They will be asking similar question. Next, let's go to next question. Page 351, question 25. 351, 25. 351, 25. Where is this 25? Scroll down a bit. This one. Okay, this is the question. Okay. Okay. Let me see. Do I have space? I think so. The presidents. We'll just go straight away. But basically, they already mentioned proportion, so you should know we are talking about proportion. Okay. The president wants to estimate to be within 0.04. Okay. In statistic, remember when you talk about expect the expected value. Expect mean finding the mean, but within mean, okay, when you want to estimate your mu, you want to estimate your population mean, so you want it to be within the number. So in estimating the number, you are making some error. Okay, so the within is telling that you are estimating it, and then you will have an error. So the error is called margins of error. That is 0.04. The word within is telling you that you are estimating and making an error. So let me write it here. What color is this? This is color blue. Okay. So error, margins of error is 0.04. Assume confidence interval is 95% because under proportion you are using Z. So your Z for 95% you will get 1.96. What else? The president's political blah 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 estimated the proportion. What is the proportion? To be 0.6. Remember, sometimes the proportion will give you X or N, X as well as N, but sometimes they didn't give you the X as well as N. They just give you the percentage. This is the example. The proportion is just in terms of percentage, which is 0.60. So they give you the P straight away. You don't have to compute. 0.6. So how large of a sample is required? So you have to look at the formula of sample size for proportion. Where is the formula? This one. Let me write it here so that you can plug in into the formula. The formula is finding the sample n equals to proportion multiplied 1 minus p z over e squared. So you have the p, right? 0.6. 1 minus 0.6 multiply with the z. Where is the z just now? 1.96 over e. E is 0.04. And then squared. You will get the answer straight away. But remember, this is a sample. So if let's say you got the answer of, I don't know, 92.1, round it up into 93. Then if let's say you get 92.002, round it up still into 93. This is a sample. Okay. Okay, I'll just skip to the next one. Exercise. Maybe the last one before we end our class. I'm trying to conserve my voice for the next class, 3:30 until 5. Okay, 356, question 49. 356, question? I forgot. 49. This one. Okay, there are 20,000 voters in South Carolina. So basically, when I read this, I know that this is the population. But maybe some of you think that, but we are talking about voters. This is the N. It's fine. Don't worry. You can just put N. Okay, N equals to 20,000. The next sentence should tell you that this is not just simply a small n. A random samples of 500. Random sample, that should be the small n. So the previous n will be your capital N. You have to remember when capital N is given, when population is given, you have to adjust whatever formula that you're going to use with the adjustment formula. Okay. So, a random samples of 500 voters revealed. So, out of these 500 people, 350 plan to vote. They also give you X, 350 to vote. What does it mean? So, now you are giving N as well as X. This should be asking you proportion. You have to use the formula of proportion and adjust with the correction factor. So, correction factor, adjust with the adjustment. So construct 99% confidence interval. This is green. Where is the okay? So confidence interval is equals to 99%. So if I still remember, because proportion, right? Proportion will always be using Z. If I still remember for 99%, we have computed it just now, is equals to 2.58. Okay, you can double check. If I'm not mistaken, this is for the 99% is 2.58. So use the formula for proportion then, and then adjusted it with this population. Okay, where is the proportion formula? This is sample size for proportion. Where is it? This is the proportion. This is the formula. Let me write down the formula. So P plus minus Z multiply with the square root of P 1 minus P over N. Okay, so you cannot solve this unless you compute the P. So how to compute the P? X over N. What is the X just now? 350 divided with N, 500. Can someone help me to find this? 350 divided by 500, what will you get?
0.7.
0.7. Okay, I'm assuming this should be correct. You have your calculator, right? So P is 0.7. So plus minus Z, you have computed it. 2.58 multiply with 0.7 multiply with 1 minus 0.7. I forgot something there. Let me just continue writing first. Over N 500. Remember, don't forget your capital N. You have to adjust it with the correction factor. I'm keep saying just correction factor. You have to adjust it with the adjustment formula. Okay, the finite adjustment formula. So, let me use different color, or else you will not notice this. You have to multiply with capital N minus N over capital N minus 1. So whatever you have here, you have to multiply with a capital N, which is 20,000. 20,000. I don't have sufficient. I do. 20,000 minus. What is this? So minus. Even my marker also doesn't want to write minus. Where is the minus one? Okay. So just put minus N. I cannot. Oh, what's wrong? Okay, let me use. Okay. I want to apply the correction. Can I just leave it to you? 20,000. You minus small n 500. Let me see what's happened. Change the color. Still the same. It doesn't.
Madam,
Huh.
you need to select the brush option.
I select what? Oh. Okay. Okay. Thank you for that. Huh. Okay. So, just be patient about this, right? Now, let me see minus. Okay. Well, somehow, I don't know what's going on, but I hope that you know, which I couldn't happy why I cannot press on my marker. What's wrong? What did I do? Let me click this pencil. The pencil is there. Okay. So let me try to adjust a bit. Okay. Okay. So 20. I want to use orange just now. So 20,000 minus small n, which is 500, over capital N, again 20,000 over minus 1. So you have to multiply with the finite adjustment formula. Okay, so giving this, you will have two value, the x1 first and the second x2. And again, although you see plus minus, many students will start with plus. No, you start with minus because minus will give you the smallest range. The plus will give you the largest range. Start with the minus and then the plus. You will get these two numbers. Okay. So, yeah, I think that's it about today's class. Wow, we are going. Is it too fast? Not really, right? Okay, so, um, exercise.
Madam, saya ada soalan. I have
Okay,
question.
okay. Should I
Uh,
stop the recording first, or you want me to proceed with the recording?
Proceed je lah, madam.
Okay. What is your question?
Then we should use the adjust
Adjustment
finite population.
You have to use adjustment when the question give you the population number. Okay. And then what is your question?
Oh, I mean when we should use the correction factor.
When? Only if when the question give you the capital N, the population number. If let's say the question didn't give you capital N, you cannot use adjustment formula. Clear?
Thank you.
Okay. Anyone else? Anyone else? No? I know that you want to go home quickly. You are at home, right? Okay. So let me just close the record, end the recording first. Let me see. Manage recording. Stop recording.